Welcome back, everybody, to the deep dive. This time, we're going to be taking a look at some really cool research on automated debugging.
Yeah.
We've got a couple of articles here about this new technique called UTGEN,
Okay.
and another one that builds on it called UPDebug.
Hmm.
And both of these have the potential to really shake up how we think about AI writing code.
Oh, for sure.
Hmm.
It's a fascinating area. We've gotten really good at building these large language models, LLMs. They can actually write code.
Right.
But one of the biggest challenges is that they aren't so good at knowing if that code is actually correct or not.
Yeah, that makes sense. It's like if you wrote an entire essay
Hmm.
and just turned it in without having anyone, like a teacher, check it over first,
Right.
you'd have no idea if you totally nailed it or made some major mistakes.
Exactly. That's a great analogy. And that's where unit tests or UTs come in.
Okay.
Think of them like a bunch of mini quizzes, each one testing a tiny piece of your code. And just like with those quizzes, you can use them to figure out exactly where things are going wrong.
Oh, okay.
So for these LLMs, unit tests are key because they provide that essential feedback loop.
So how do you create good unit tests, though?
Yeah.
For something as complex as an AI that writes code?
That's the big question, isn't
Yeah.
it? You need a system that can generate tests that are challenging enough to actually find errors. Researchers call that a high attack rate.
Okay.
But it also needs to know what the right answers are. Otherwise, you're giving the LLM bad feedback, and it'll actually learn the wrong things.
That's where UTGEN comes in, right?
Yeah,
It's like teaching the AI to create its own study guide, complete with tricky practice questions.
yeah, precisely. UTGN is trained by taking existing code and intentionally introducing errors, almost like creating a practice test with common mistakes built in.
Oh, okay.
And then it learned to both generate tests that will catch those errors and figure out what the correct output should be.
So it's not just learning to spot errors, it's also understanding the logic behind the correct solution.
Exactly. It uses what's called chain of thought reasoning.
Mm.
It's basically like forcing the LLM to show its work.
Right.
So it develops a deeper understanding of the problem and how to solve it correctly.
Do the researchers give any specific examples of how this works in practice?
Yeah, they do. One example from the research is the next smallest palindrome problem.
Okay.
So let's say the LLM wrote a function that's supposed to find the next smallest palindrome of a given number.
Okay.
Now, if the code has a subtle error, a basic test might not catch it. But UTGEN learns to create more sophisticated tests that are more likely to expose those flaws.
So instead of just checking if the code can find the next smallest palindrome of, say, 120, which is pretty straightforward, UTGEN might come up with a trickier test case that would reveal a deeper error in the logic.
Exactly. And that's a big part of what makes UTGEN so innovative.
Mm-hmm.
It's not just generating random tests. It's learning to create tests that are specifically designed to be challenging and catch those subtle errors that other methods might miss.
That's really clever. But how do we know if this actually works in practice? Did they actually test out UTGEN
Yeah.
to see if it made a difference? So they took UTGEN out for a spin.
Yeah, they put it through the ringer, you could say.
Oh, cool. So how did they do that?
Well, they use these data sets that are specifically made for debugging. Things like human evil plus fix and MBPP plus fix. These data sets are full of real-world code with really tricky errors. Like even experienced programmers would struggle with this stuff.
Oh, wow. Okay. So what they did is they compared how well different LLMs could debug code
Right.
when they had UTGEN generated tests versus other methods, like, not having any tests or just random tests.
Yeah, exactly. And the results were really impressive, actually.
Really? Okay. So spill the beans. What happened?
Well, UTGN consistently improved debugging success across all the different LLMs they tested. But here's the really interesting part.
Okay.
On MBPP plus fix, the one with partially correct code, UTGEN boosted the accuracy by over 12% compared to having no unit tests at all.
Whoa. Okay. That's a pretty significant jump. So it sounds like UTGEN is showing a lot of promise when it comes to making these LLMs better debuggers.
Yeah, definitely. It's really exciting. But
Yeah.
like with any student, I guess there's always room for improvement, right?
Right.
Did they find any limitations with UTGN?
Yeah. What are the limitations?
So even with all this training, the tests from UTGN aren't always perfect.
Oh, okay.
And that's where UTDebug comes in.
Okay.
It basically builds on UTGN to deal with that problem, like those, less than perfect tests. Think of it as another level of quality control.
So UTDebug is like the teacher double checking the answer key.
Yeah, before handing it out to the class,
Right.
making sure there aren't any mistakes.
Okay.
Exactly. UT-Debug uses some pretty neat tricks to refine those tests. Like one technique is called test time scaling,
Okay.
where the test is actually run multiple times with little variations each time. It's kind of like getting a second opinion
Right.
on a tricky question.
Yeah, yeah.
If the answers all agree, then UT-Debug can be more sure that the test is accurate.
Makes sense. So it's basically adding this extra validation step to make sure the tests are reliable.
Yeah.
Is there anything else that UTBug does to kind of improve those tests?
Yeah, it also has this backtracking system.
Oh, okay.
Sometimes the LLM might make a change based on feedback from the UT, but that change could actually make the code worse overall. So UT-Debug keeps track of these changes, and if it sees a particular edit is causing more problems than it's solving,
Right.
it can basically undo that and try a different approach.
So it's like preventing the LLM from like going down a rabbit hole of bad edits.
Exactly. Yeah, it's like a safety net
Oh,
to make sure the learning process stays on track.
did they find that these extra steps in UTDebug actually made a difference?
Oh yeah, big time.
Really?
They found that if you take away either test time scaling or backtracking,
Hmm.
the debugging performance actually gets worse.
Oh, wow.
So that really shows how important those techniques are in making sure that the debugging is reliable and accurate.
Wow. That's fascinating. It really highlights how much work goes into getting these systems to work well. It's not just a matter of, like, throwing AI at the problem. It's this really careful process of engineering these safeguards, checks and balances.
Yeah, for sure. I mean, UTGN and UTDebug they're kind of like a dynamic duo working together to really make those LLMs better at debugging. But,
Yeah.
it's important to remember that this is all still research in progress. It's, a step in the right direction, but there's still a lot more to learn.
Yeah, for sure. For sure. So where does all of this leave us? I mean, in terms of the bigger picture, what are the real world implications of all of this? Imagine, if we could have AI that can not only write code, but also debug it effectively. What could that mean for the future of software development?
Yeah,
Yeah.
it really is. It's mind-blowing to think about what could happen, if we can get to the point where AI can write code and debug it all on its own.
For sure. I mean, it could totally change how we do software development. It
Right.
could free up developers to work on the more, I guess, creative parts of software, the design and the strategy, and let the AI handle the tedious stuff like debugging.
Yeah, totally. So it could make us way more productive and lead to more innovations.
Absolutely.
I can already imagine these teams of human developers and AI developers working together, each one using their strengths to build even better software.
Yeah.
But as cool as that sounds, it also brings up some pretty big questions, right? Yeah, definitely. Like, if LLMs can learn to debug their own code, what's next? Could they learn to see problems before they even happen? Or even work together,
Oh, wow.
share their knowledge, and make even more amazing solutions?
It's kind of crazy to think about all the possibility. We're talking about AI that could do things that we thought only humans could do.
It really makes you think about the future of work
Yeah.
and how humans and AI will work together. But I think for now, we should just appreciate how cool U2GEN and UT-Debug are.
Right.
They really show how much progress we're making in AI.
Yeah, it's a good reminder that even with all this crazy AI stuff, testing and debugging are still super important.
Absolutely.
And who knows, maybe UTGN and UTDebug are just the first steps toward having AI that can program completely on its own.
That's a great point.
That's some food for thought. Thanks for joining us on this deep dive, everybody. We'll see you next time.